Lecture, Chapter 5, Section 1, Temperature, Thermal Energy, and Heat. Make sure you read the essential questions, the vocabulary review, and new vocabulary. There will be a vocabulary quiz. Temperature. You can use the words hot and cold to describe temperature. Something is hot when the temperature is high. When you heat water on a stove, its temperature increases. How are temperature and heat related? All right, so this brings about the kinetic theory of matter. It just calls it right here matter in motion. This is super duper important, okay? From astronomy on down to physical science here. All matter is made up of tiny particles. Those tiny particles, we're going to explore their atoms and molecules, but right now we're going to call them tiny particles. So all matter, anything that takes up space and has mass, all matter is made up of tiny particles. These particles are in constant motion. They're always moving. They're vibrating in place. Some of them move around, but they're just moving all the time. Okay. So all matter is made up of tiny particles. Those tiny particles are constantly moving. At a higher temperature, they move faster. At cold temperatures, they move slower. At the same temperature, more massive particles move slower than less massive particles. That is known as the kinetic theory of matter. So the matter in motion, right here, matter in motion. The matter around you is made up of tiny particles, atoms, ions, and molecules. In all materials, these particles are constantly randomly moving. They move in all directions at different speeds. These particles have kinetic energy because they are moving. The greater their speed, the greater the kinetic energy. If the particles that make up an object have more kinetic energy, then that object feels hotter. For example, the particles that make up the electric stove burner on the left have more kinetic energy than the particles that make up the burner on the right. As a result, the burner on the left feels hotter than the burner on the right. Is there a more exact relationship between temperature and kinetic energy? Basically, listen, man. Kinetic energy, when we feel something and it's cold, the particles are moving slow. When you feel something and it's hot, the particles are moving faster. Temperature is a measurement. Temperature is a measurement of the speed or the kinetic energy in the particles of an object. Okay. So in this stove example, this side is cool. Remember the kinetic theory. When it's colder, they move slower. All right. When it's hotter or warmer, the particles move faster. Kinetic energy of the particles, when we measure the kinetic energy, it's called temperature. The temperature of an object is the measurement of the average kinetic energy of the particles that make up that object. The temperature of hot tea is higher than the temperature of iced tea. Therefore, the particles that make up the hot tea have more kinetic energy on average than the ones that make up the cold tea. Thermal energy. Now, just like mechanical energy, if you remember from last chapter, mechanical energy is potential energy plus the kinetic energy added up in a system. Thermal energy is the energy of the particles that make up an object, right? Thermal energy is the addition of the potential energy of the particles and the kinetic energy of the particles. The energy of an object is the sum of the thermal energy of an object is the sum of the kinetic energy and the potential energy of all the particles that make up that object. All right? Temperature and thermal energy. Thermal energy depends on temperature. The average kinetic energy of the particles that make up the object increase when the temperature increases. So thermal energy will increase as kinetic energy increases. Mass and thermal energy. Thermal energy also depends on mass. If the mass of the object increases, The thermal energy of that object also increases. Why? Is because to have more mass, we have to add more matter. Heat. Heat is pretty cool stuff. The study of thermodynamics deals with heat. When you get up in the morning and you go to the bathroom, you go and sit down on the toilet seat. If you're the first one in there, the toilet seat's cold, right? The heat, the object that's hotter, um, warms up the cooler object. So, in other words, your rump, your rear end, warms the toilet seat. The heat leaves your rear end and heats the toilet seat. You get up, if you're like me, at my house, I have hardwood floors. If I get up barefoot in the morning, the floor's cold. The heat leaves my feet and tries to heat up the floor. Heat flows always from hot to cold. It's never reversed, okay? Unless we use some kind of a machine. So heat always flows from hot to cold. Hot to cold. If you go outside and you grab the cold fence or the cold door handle, the heat leaves your hand and tries to heat the door handle. If you get up in the morning, you're the first one in the shower. The shower floor is cold because your feet, the heat is leaving your feet and trying to warm up the shower. Now, the kinetic energy in an object, like let's just say your hand, you grab a cold piece of metal, like believe it or not, even right now, if you're in school and you grab the metal on a desk, you'll feel it's cold. It'll remain to feel cold until the kinetic energy of the particles in your hand makes the metal warm up until its particles in the metal are moving the same speed as the particles in your hand. Then that transfer of heat stops. So heat is energy that is transferred between two objects due to a temperature difference or a kinetic energy difference between those objects. Warmer objects always heat cooler objects. That's why if you put your hand on this hot stove, you're going to burn your hand. It's hotter than your hand, and it's going to transfer that kinetic energy into your hand. It never goes. If you touch that, your hand doesn't cool it off. All right. It's going to burn your hand. Heat always flows from hot to cold, hot to cold. We can measure the specific heat. The specific heat of a material is the amount of heat needed to raise the temperature of 1 kilogram of the material by 1 degree Celsius. Scientists measure specific heat in joules per kilogram degrees Celsius. And here's the units. Table 1 compares specific heat of some familiar items. Now, I will tell you, to measure specific heat, we use what's called a calorimeter. And this question, there might be a question in this on your homework about the calorimeter. We really don't use it as much as we used to in school, just simply because measuring specific heat is no longer part of the curriculum guide, or it's not a standard set by the state of Ohio. But we do use a calorimeter to measure specific heat. Make sure you read this to understand how a calorimeter works. All right, that is it for this lecture.